Hey people, hope you're doing great. We're going to start chapter 6 today. Hold on, that camera looks a little crooked. Oh, there you go. Maybe a little bit better there. Chapter 6 today, we're going to start in 6-1, of course. We're going to be on page 298, 299. So get excited. We're going to have some fun today. I think you're going to like this. It's a nice change from what we've been doing in the past. All right, you guys ready? Here it comes. Hopefully we get volume.
How does a translation affect the properties of a two-dimensional figure? Think about this question during the lesson. A landscape architect shows a plan for a new patio to a client. The client wants the fire pit moved 6 feet to the right and 3 feet farther from the house. Where should the architect place the fire pit? How will the client's request change the fire pit? To think about where to place the fire pit, first, how can you represent the problem situation?
All right, so a little bit different here. We're talking about these things called translations, right? It says we're going to move this fire pit 6 feet right, 3 feet further from the house, like 3 feet away. Where should we place the fire pit? How will the request change the fire? Like, is the fire pit going to change like its actual like shape and size? Of course it's not, right? It's going to be the exact same thing. We're just going to move it over somewhere, okay? So these are these things we call translations, right? We have many what we call rigid motions. We'll get into them as we do 6-2 and 6-3 and 6-4. All right, this is our first one, though. Translations, we also call them slides. Sounds fun, maybe.
A transformation is a change in the position, shape, or size of a figure. A translation is a transformation that moves every point of a figure the same distance and the same direction.
There we go.
Which property of the fire pit will the architect change?
So when we talk about properties, these are our 4 properties, okay? Sometimes when we do these moves or these motions, some of the properties will change, some won't change, right? Some stay the same. So it wants to know which one will change. So, right, is our orientation of the fire pit going to change? Is the shape going to change? Is the size going to change? No, those are all going to be the same. What will change is its position. It's going to move to a new spot.
The architect translates the fire pit 6 feet to the right and 3 feet away from the house. Yep. This is the original location of the fire pit. This is the new location of the fire pit. The fire pit has been translated. Each part of the pit has been moved an equal number of feet to the right and an equal number of feet away from the house.
Yep.
The fire pit still has the same shape, size, and orientation.
Okay. Keep going. We're almost through. Don't worry, the fun part's
now
coming.
You know how a translation affects the properties of a two-dimensional figure.
Or at least we hope we do. Okay? So again, we're going to talk a lot about properties and how they change. Here's what we have. Clients also want the small table below the window moved 5 feet to the right. Right? Where should the architect place this small table? Well, if you read the problem correctly, it said they wanted it moved 5 feet to the right. All right? So, everybody find the small table. It's below the window. It's right here. Okay? Hopefully that came, yeah, you go, right there. So guys, it's just going to move 5 feet to the right. Okay? So it's literally just going this way 5 feet. So now maybe it's right over here. Again, it's the same shape. It is the same size. It has the same orientation. That doesn't make too much sense to us right now because we don't know what that means, but we'll get there. Same orientation, and the only thing that's changed is its position, right, where it's located. Okay? Awesome. Example 2 coming at you. You guys ready for it? I think so. Look at the next page.
Polygon ABCD has vertices A, -1, 6, B, 4, 5, C, 2, 2, and D, -2, 0. Graph and label the vertices of ABCD and A prime, B prime, C prime, D prime. Its image after a translation of 8 units down and 3 units left.
Okay, a lot going on here, so let's quickly talk about it. So we can all imagine what this would look like, right? So these are 4 points on a coordinate plane. That's nothing new for us. And then it says graph and label the vertices, right? The vertices, guys, are each one of those points, A, B, C, and D, okay? And then we have to label them A prime, B prime, C prime, D prime, right? So when we have those little prime marks after it, so that's like, hey, A was the first point, then we moved it. In this case, guys, how are we moving it? 8 units down, 3 units left, right? That new point is going to be A prime, right? It's got a little tick mark next to it. All right, so anyway, let's take a look at what they did here. All right, so here is those 4 points. Beautiful. They've graphed it. Translate each of those 4 points 8 units down and 3 units to the left, right? So that literally we're just taking A. We're going to go 1, 2, 3, 4, 5, 6, 7, 8 down, 1, 2, 3 to the left. We're going to put a new point, right? That's where A prime is going to be. All right. Here, let me zoom down real quick. Well, maybe that's all the further we're going to go. Okay. All right. So there we go. So we have an image and a pre-image. All right. So the pre-image, guys, is what we started with, right? What came first? Okay, that was just A, B, C, D. The image is what comes after. So that's the A prime, B prime, C prime, D prime. All right, so I know there's a lot of new words today. So we've got translations. We also call them slides, right? We have pre-image and image, right? We've got all those different orientation, position, shape, size, all that stuff. So lots of new stuff, but it shouldn't be too hard for you guys to handle. Again, this is one of the things we're going to have to do. We're going to have to take vertices, points on a coordinate plane, and translate them. Move them up, down, left, right. Okay? All right. Last one. This will be fun. I promise.
What is a rule that describes the translation that maps trapezoid PQRS onto trapezoid P prime, Q prime, R prime, S prime?
All right, so pre-image, image. Which one is the pre-image? Black or blue? Which one is the image? Black or blue? Well, guys, pre-image is going to be the one that came first. That's the black one here. Image, one that came second. That's the blue one over here. All right? Again, easy to note if you look for the prime marks, right? Here is P, here is P prime. So if they're going to describe a rule, we want to describe it 2 different ways, right? And they're going to do the first one for us here. They're going to describe, here you go. So each vertex of the trapezoid is translated 1.5 units to the right, because it went some amount this way, and then it went some amount up, and they figured out it goes 1.5 to the right and 2 units up. Literally, it's just counting. We got to make sure we understand the scale that our coordinate plane has, okay? The second way we're going to write this is with what we call, I don't even know if it has a name, but we're going to write it like an ordered pair, guys. So if we think about every ordered pair in the world, right, we know it has an x value and a y value. Well, we can take this information here, 1.5 units to the right, 2 units up, and we can write that so that we don't even need a graph. We just need to know the ordered pairs, okay? So if we move 1.5 units to the right, is that a move along my x-axis, or is that a move along my y-axis? Well, hopefully all of you said x-axis, right? So when we move left or right, that is a move across the x-axis. And when we go to the right, we're like adding a number to that x value, as opposed to when we would go to the left, we're subtracting a number from that x value. So if we know we went 1.5 units to the right, check this out. Here's what we can do. We can say, hey, take your x value and add, that's not a very good half, hold on, and add 1.5 to it, okay? Whatever your x, right? Let's say your x value started here at -2. Just add 1.5 to that. Now you're at -1/2. There you go. Now, when we think about going up and down, of course, these are moves on the y-axis. So when we go up, right, when we go up, we can think of that like adding a number. When we go down, what would happen to that y value? Well, it's going to decrease, okay? So if we're going up, we can say y plus 2. Literally, we just get these from left or right, up or down. And then if we're going right, this is always going to be a plus. Just like if we're going up, this is always a plus. If we were going down, this would be a minus. And if we were going left, that would be a minus. So 2 different ways to write a rule, okay? The easy way is just, hey, it's going left 2 and down 4, right? This is the more meaningful way because now I can use that rule to do something with, okay? All right. Here we go. All right, I think we get to do one of these. Triangle ABC, there it is right there. Translated 5 units, right? 1 unit down. Graph and label the image. We can do that. All right, go here. So, A was here. What's it going to happen? It's going to go 5 right, 1 down. Literally, it's nothing more than 1, 2, 3, 4. 5 right, 1 down. There it is. Showed up okay. Same thing with C. It's going to go 5 to the right and 1 down. So 1, 2, 3, 4, 5 right, 1 down. Right there. Same thing for B. 1, 2, 3, 4, 5 right, 1 down. I don't really like the color of those. Okay. All right, here we go. Bam, bam. There, much better. Okay. Go ahead and connect these like so. Remember, we're going to call this A prime. This is going to be C prime. And this will be my friend B prime down here. Okay? Now, here's the rule. They gave us that. Let's try to write that rule just like we did a second ago. So 5 units right. Again, that's an X. So think about, are we going to go X plus or minus that number? And then 1 unit down. Again, that's a Y value move. Is that going to be plus or minus that 1? Right? So 5 units to the right, X plus 5. 1 unit down, Y minus 1. Okay? And guys, here's how this works. So let's take this coordinate point A here. Guys, this is at -2, 3. -2, 3. If I want to know where A prime is, right? -2 plus 5, 3 minus 1. That will be your ordered pair for A prime. I guarantee it, right? What's -2 plus 5? 3. What's 3 minus 1? 2. Is A prime located at 3, 2? 1, 2, 3? It sure is. Ha ha. So guys, that's why this rule can be very helpful. Because at some point in time, they're going to give me a really bad ordered pair, but they're going to give me a rule, or I'm going to have to come up with a rule, and then figure out the new ordered pair without a graph, okay? And this is a simple way to do that. Now, it asks a question about this angle. It says that the measure of angle A, they're saying this angle right here, right? If that is 30 degrees, what is the measure of this angle here? What would you guys think? Would it be any different? Absolutely not. We did not change, right? The shape, the size, any of that stuff with this one. So this angle is still the same as this angle here. Just like angle C and angle C prime are identical. It's the same angle measure. Okay? Okay. So guys, I think that's it for the funness right now. We'll probably get into our key concepts, right? So if you want to flip the page, you can say goodbye to this video, and I should be back doing key concepts here in just a second. All right? See you guys there.